Okay, so these are what I refer to as focus activities. They're just like little bell ringers. You'll probably get these once or twice a week. And you'll notice they are numbered. Okay, this is the very first one for the first 6 weeks, and we're going to have them all the way through the last 6 weeks. But this is another opportunity that I'm going to provide you to go ahead and get a very easy grade. Because however many we have, I think in the first set, and we do 2 sets per 6 weeks, I'm going to go ahead and collect those at some point, and then that's going to go in as a quiz grade. Okay, so I would like you to, when you see one of these, try to work it out, yourself, and then I'll come up, we'll go ahead and work it together, but, don't wait for me to go ahead and kind of walk you through the problem. Think if you could solve it yourself, because you never know if something like this may show up on a test or a quiz, could even show up, something very similar on the paper exam. So it could be review material, it could be over the current material. This is just some good old Algebra 2 problems, a little bit of IB that I pulled out for this. So you'll get the first one today. I believe we're going to do the second one on Friday. We'll do the third one early next week, and then we'll go ahead and turn those in prior to progress reports. Get ourselves another quiz grade. So really, all you have to do is follow along and hold on to these. Keep them someplace safe. Okay. So let's see. Number 1. In the last 6 years, the value of a house increased by 35%. If it cost $72,000 6 years ago, what is its value now? So how would I set this up? What type of function does this describe?
Don't you just multiply 72,000?
You're forgetting one thing. It was 6 years ago, so 6 years has passed. So it is increasing by 35% every year. So what kind of function was I referring to? Starts with an E? Exponential. Okay. So we have our initial amount, 72,000. I don't want to do this spread.
Well, no, it just increased by 35% in the last 6 years. It's not per year.
Oh, that's right. So that one's not specific. So it doesn't say per year. So it just say what? So you are absolutely right. Yes, you are correct. I'm sorry. So we don't need to raise it to the power of 6. I still want to live in that house though. Okay. So my base would be 1.35 because 1 would represent the initial value, the 100%, and then plus the 35% growth that we're going to have. So it would definitely have to be larger than 1. You're absolutely right. So 72,000 times 1.35. 72. Let's see if this is going to work for me. This is the first time I've used the calculator this year. I'm getting 97,200.
Yeah.
Okay, I don't know if there's any change there, so we're good. Okay. And there we go. He's absolutely correct. I read that as per year. That's not realistic, but there you go. All right, so that was exponential. Questions? Okay. Well, let's take a look at number 2. Calculate the circumference and the area of a circle with a radius of 4.3 centimeters. Write your answer in 3 sig figs. Okay, so what's the circumference? There are actually 2 formulas. What would you like to use? Yes, sir.
Since it gives us a radius, we can just use 2 pi r.
2 pi r, okay. Or we could double it and still use pi d if we wanted to, but essentially it's the same. So the circumference is 2 pi r, so 2 pi times, in this case, 4.3. Okay, so push enter. So 2 times, and we probably could have just doubled that ourselves, but oh well. I'm going to show you more about the calculator. It's probably going to be on Friday for the first time. Then I'm going to go ahead and go back and revisit frequency tables, histograms, and start showing you how to do that on the calculator. Okay, but I'll use this button down here, and there's going to be a lot of different ways to go ahead and get these symbols, but in the bottom left corner, you've got the button with pi on it, and there's a lot of very useful symbols here. Okay, so I'm going to go ahead and choose pi times my 4.3. Okay, so to 3 decimal places, well, not 3 decimal places, 3 sig figs, what would that be? 0.0, there we go. Okay. Okay, because that 0 is still a placeholder. Okay, and we're talking centimeters. Okay. And then, of course, what's the area, the formula for area of a circle? Radius squared times pi. Okay, so pi r squared. So pi times 2. 4.3 squared. Okie dokie. Come on down here again to pi times 4.3 squared. All right. Now to 3 sig figs. 58.1. 58.1 square centimeters. Okay, so that's easy enough. That's pretty basic. And then our last one here, number 3A. A model train is a 1/25th scale. Express this as a ratio. Now, I know this might seem kind of confusing because we can sometimes use the word interchangeably, ratio with fraction. But does anybody actually know what I'm referring to when I say this?
Isn't it just like the number, colon?
Yes, there you go. We just go ahead and express it using a colon. So 1/25th or 1/25. Okay, that's what it's referring to. Okay, good. B, if the length of the model engine is 7 centimeters, okay, then what is the true length of the engine? How do I figure that out? There you go. Multiply by 25. You can easily set up a proportion. Okay, but just help me out. What is 25 times 7? Okay, so 175 centimeters. Now, it didn't ask me to go ahead and change it to anything. We probably could go ahead and convert it to inches if we wanted, but I'm not too interested. Does anybody want to write out a proportion? Yes, ma'am.
So how did you know which one to multiply by?
Well, that's a good question. So tell me, why did you just go ahead and multiply by 25? Hey.
So essentially the ratio is model engine to regular engine, right? So if the model engine is multiplied by 7, so 7 over S.
Okay. And that's exactly what it's talking about, and that's why I said proportion. So we have this original scale, 1/25ths, so I know that the model is 7 centimeters, so how many centimeters would that be in real life? So that's why we multiply. Okay. Very good. Any questions? All right, go ahead and put that someplace safe so we don't forget about those. Binder or folder, whatever it is you want to do. Do you want to save changes? Yes, why not? Okay, this here. So let's get back to this. Okay, so cumulative frequency. Did anybody happen to go home last night and start to fill in the table? Okay, a few folks. Okay, thank you very much if you did. Okay, if not, that's fine. We have this right here. So let's see what it is we're saying. Let me go ahead and get out of the way. Does everybody still have the notes from yesterday? Okay, if you don't, there should be some extra copies right over there on the door. But it says the relative frequency of an event is the frequency of that event expressed as a fraction or decimal equivalent of the total frequency. Remember, the relative frequency is a what? It's a percent. Okay, we've been dealing with those when looking at the frequency tables. The cumulative frequency of an event is the accumulation or the sum of the frequencies up to and including that event. These are very useful at helping us create and find percentiles and a graph that we can visualize the data. So here's my column for cumulative frequency. All right. And everybody's okay where I got these numbers from for the original frequency? So you've got your set of data. If you were to go through, for example, I see a length of 0.65 once. I saw 1.25 twice. Okay, well, the cumulative frequency means to start with the first frequency number that I have. But as I start to move through all the values in my set, I'm going to begin to add the frequencies that I see. Okay, so the next frequency is 2, so the 1 plus 2 will give me 3. See, I'm accumulating frequency as I go down the table. Okay, so then the next frequency is 2, so 3 plus 2 will give me 5. Okay, does everybody see how this is working? That's how you fill in a cumulative frequency chart. Well, let's just go ahead and keep going. Tell me what the values are. 5 plus 1, 6. 9. 11. Okay, 14. 17. Okay, 22. 31. 42. And 50. And do you notice anything? Okay, we have 50 elements in the set. Okay? The very last one for cumulative frequency should be the total number of elements that you're dealing with. Okay? So we've already got the relative frequency here because I wanted you to go ahead and see something. Some of these, like 2/50ths, what can you do with those? You could definitely go ahead and simplify those. We'd want to go ahead and say 1/25th. But I left it like this for a specific reason. You should be able to add all these up. So that's why I kept them all as 50ths. Okay. 50/50ths. There we go. Because think about this. We said that the relative frequency was what? That's a percentage, right? Well, 50/50ths is 1. So that represents 100%. That's all the data we're looking at. Okay, that should be happening when you're dealing with these types of tables. So the cumulative relative frequency, that's still a percentage. But what you're going to be doing is adding those as you go along. Does that make sense?
That makes sense. Like
So you start with 1/50th plus 2/50ths would be 3/50ths plus 2/50ths, 5/50ths. And do you notice anything? Yeah. Isn't it the exact same as the cumulative frequency I had here? And you would expect that because you're just adding those values again. Okay. And of course you would want to go ahead and simplify those, but again, I'm not too worried about that. Everybody can, simplify fractions. So I'm just going to go ahead 6/50ths, 9/50ths, 11/50ths. Then we got 14/50ths, 17/50ths, 22. We're almost there. And then finally 50/50ths. Okay. So again, we get to the end, 50/50ths, there's 1, you're 100%. Okay. But the main thing I want you to go ahead and see and understand is this cumulative frequency column. I'll go ahead and say I can't talk today. All right, is everybody okay with how we found those values? Spencer?
On the test for the relative frequency, do you want that as a fraction or as a percent?
I like dealing with fractions. A lot of times when you're dealing with the actual math, you'll probably want to deal with decimals. But I just think everybody could always use more practice with fractions. I mean, would that be a fair statement for a lot of folks in here? Okay. So I'd say fractions, but I mean, as long as it's equivalent, I'm not going to quibble over it. I'm not going to count it wrong or anything. Eli, you okay?
yeah, I'm good.
Okay. All right. Well, there we go. So we got the table filled in. Does anybody need me to leave this up here for another second? We're good to go? Okay. Well, let's see what else we got. It says rework the data above by creating 6 class intervals for the above data using the intervals as shown below. Okay, so we've gone ahead and now classified these. So we did start knowing what the links were. Okay, but now we're going to go ahead and pretend, let's say we don't know what that was. We're just going to take the information from the table. All right, like for example, from the table, we're not going to go back to the data. How many of the links were between 0 and 1?
1.
Yeah, we only have the 1 right here. Okay, so tally 1, frequency 1. How many were between 1 and 2? I want to say yes. I believe that is. Got my notes right here. Oh, I got 5. Yes. I got 5. And let's go ahead and say between 1 and 2 if I'm looking at the table. So let's see. We have this one, this one, this one. But don't forget about the frequency. So 2, 4, 5. Okay, so 5 of those elements are going to be in that particular class interval. Okay. So 1, 2, 3, 4, 5 tally marks. And between 2 and 3, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Between 3 and 4, 3. 1, 2, 3. Between 4 and 5, 14. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. And between 5 and 6, 19. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. And I'm not going to go ahead and put all those tally marks for the total, so don't worry about that. All right, I got the 19. We're good to go. All right. And we're still dealing with how many items here? 50. So 1 plus 5 plus 8 plus 3 plus 14 plus 19. There's my 50. Okay. So let's go along with the cumulative frequency as I see them in the class intervals. Okay, so is it Gabby? Correct? I'm going to start with the first one. Would you tell me the second one? 6. Okay. Libby, can you tell me the next one? 14. Very good. Okay. As a Kareem? 17. Okay. Spencer, next up? 31. Okay. Is it Kiara? What's the next one? What's that mean? It is 50. Okay. There we go. Now I want to go ahead and take a look at the relative frequency, okay, which is just the percentage. So in this case, what would the very first one be? 1/50th. Okay. And then this one, I'll go ahead and write it and simplify it, okay, since we're condensing the table. So now, this isn't the cumulative relative frequency, so would it be 5/50ths or 6/50ths? This one would be 5/50ths. So 5/50ths would be, okay, 1/10, right? Ooh, that was close. It almost got 2/10 in here. 2/10. I got, hey, there, she enjoyed it. There you go. My job is done here. Okay. Eli liked it too. There you go. All right. You'll laugh later, trust me. Okay. Anyways, next up, what do we have for the next cell? 8/50ths. And what would that be? Okay. 4 what? 4/25ths. Then we got 3/50ths, which will not reduce. And then we got 14/50ths, which would be 7/25ths. And finally, 19/50ths. Okay. And then, of course, we could go ahead and get a total there, which, again, should be what? 50/50ths, your 100%. Okay. Now, the cumulative relative frequency, we're going to be looking at this particular column. Okay. So that would be 1/50ths. But then the next one would be what? 6/50ths, which is what? 3/25ths. Okay. And we have 14/50ths, which we've already said is 7/25ths. Excuse my writing. I'm trying to fit it as well as I can. Then the next one, 17/50ths. Okay. And, I can't help but notice, because I try to keep up on the current trends, because I teach in high school and, what's important to you guys. Every time I hear two numbers together, and I think, I hear the first one is 17, really hoping the next one will be 38. 1738. So, see, I know it's older, but I do try to keep up. I don't know a lot of current stuff. Okay, anyways. What's next? 31/50ths. I may be old, but I'm not dead. Okay. Here we go. You got me, man. Now, I recognize the song, but no, I ain't gonna be able to. Who is the rapper? Who? Fetty Wap? Fetty Wap.
Like confetti?
Like confetti.
Confetti.
Fetty.
Confetti. What?
Fetty Wap. Okay, this is probably a dumb question. Is that done to the wap, 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 wap? Is it anyone who did the song? No.
I do know that was a song, but I don't think it's like.
Oh, whatever. It's not? Okay.
Fetty Wap is plagiarizing another guy's
All right. And then we got our 50/50ths. Okay. But there we go. All right, so how are we doing with cumulative frequencies? Everybody starting to see the idea? Okay. So as far as using it, finding the values, there's not a whole lot that goes into it. You probably won't be doing a whole lot with the relative frequencies. That's just something that you need to be aware of. I've never seen it as of yet show up on one of the paper exams. I could be wrong. Maybe they'd make this next year the one. But let's go ahead and start looking at how we can use this. Now, the first thing it says, create a frequency histogram of the steel rod data and add a frequency polygon for the data. Now, we talked about frequency polygons just a moment ago, or actually yesterday. What I'd like, I've done a couple of these. Can we now get somebody up here to give me a frequency histogram for this table that we just created? Okay, so we know the frequency, we know the class intervals. Eli, you want to go try it?
Yeah.
Okay. Sure. Absolutely. Absolutely. That's okay. I embarrass myself every day. So
the bottom is going to be the rod length. This would be like 1. Wait, that's a 2. How's it guys? And it goes all the way to 6. 1, 2, 3, 4, 5, 6. We got plenty of room. Writing's hard, guys. Then the top goes 1, 2, 3, 4, 5, 6, 7, 8. So it's just looking out for me.
okay. Now I see what he's saying, but wouldn't the intersection still represent 0?
Well, I don't know. It's just to keep it off, like the.
Yeah.
Oh, okay. Okay. Okay.
This could be -1.
Okay.
See a -1 length, guys. Our pipes inverted. And then
Now there is also one other thing we have to keep in mind when we're going to create the frequency histogram. Gabby? Okay, now remember, do we know what the actual elements are? Oh, I'm talking about the actual values in the set. Like, do I know all of the lengths, all 50? We do, right? That was how we filled in the very first table. Okay, well, it's good that we've kind of put that out of our minds because we're focusing on the table that's got them divided up into class intervals. So we have to pretend that we're going straight from this guy right here, that we don't know what the specific numbers are going to be. Okay, so what are we going to use for a class interval with the frequency? What did we use to find the mean? Starts with the M. The midpoint. So we're going to go ahead and use the midpoint along the horizontal axis, and then we can set the frequency by the number of times it appears in that interval. Does that make sense? Everybody's okay? Okay. Just wanted to make sure that we were doing that. So like between 0 and 1, what's the first midpoint?
0.5.
0.5. Okay. And I mean, we can go ahead and use this. I just want to make sure that you realize we would have to use the midpoint. Everybody's okay? Yes. Okay.
To do the
All right.
polygram, right?
Mm-hmm.
Sweet. And then our frequency goes up to 19. And we only have 1, 2, 3, 4, 5, 6, 7, 8. We only have 8 things. By 3.
By 3s would be good.
Yeah. So 3, 6, 9, 12, 15, 18, 21, and then 24. Don't really go up that high, but we'll write 24. Sweet. Now we just draw the lines on the table. So from 0 to 1, we have 1. That's not really a 1. I'm marking the whole. And then 5, 8, and then 3. That's a nice one. Can't they all be multiples of 3? 14. And then perfect.
Would you guys agree?
Anybody's questions?
I would agree.
Perfect. Do you want me to do the polygraph too?
The frequency polygon?
Yeah.
Do you remember how to do it?
Yes. Can I try it? And
Perfect.
Just tell me if I'm wrong.
Okay.
So we're just like connecting the midpoint, right?
Yes, yes, yes. So this is another way to kind of see visually how the data is going to be distributed. Remember, we had normal distribution, right skewed, left skewed. Okay. And then it would just come back down. Yeah.
Oh, it comes right down. Sorry.
There you go. There we go.
Okay.
Okay, I'd say that's good.
Did it again.
Perfect, perfect, perfect. Okay. So how are we doing on cumulative frequency? Not too terrible? Caitlin, what do you think? What do you think, Caitlin? What do you think, Caitlin? What do you think?
Yeah.
Yes. Okay, there we go. Yes, ma'am.
So we didn't use
No. This was just kind of a refresher on what we did in the previous one. Now here, this is where the cumulative frequency is going to come in. In fact, this is tomorrow what we're going to start with after the quiz. I'm going to go ahead and show you your first cumulative frequency graph, and I'll show you how we can find those percentiles. Okay. All right, good. The bell is about to ring. So very quickly, if I can get you to put your calculators back over here. Guys, you did a great job today. I do appreciate it.